Welcome Pure Maths 1 students to week 9 of maintenance. Looking at quadratics first, we've got a curve y squared is equal to 12x and it intersects the line 3y equals 4x plus 6 at 2 points, and we've got to find the coordinates of the 2 points. Okay, so my first step here would be to rewrite my second equation, the line equation, as y is equal to 4/3 x plus 6 over 3, which is 2. And now that I know what y is, I can put that value of y into my curve equation. So therefore, 4/3 x plus 2 all squared is equal to 12x. Now when I expand that, I'm going to get 16 over 9 x squared plus 16 over 3x plus 4 is equal to 12x. At this point I'm going to times everything by 9 to get rid of the fraction, so I'll get 16x squared. And then when I times by 9 there, I'll end up with the 16 over 3. It'll be like 3 times 16, which is 48x. Yeah. And then I'll get 36 here. And 12 times 9 is 108, so I'll get 108x here. Now I'm just going to move over to here to continue my working. I'm going to bring everything across to the left-hand side. So I'll get 16x squared. What's that? Minus 60x. Plus 36 is equal to 0. Now, what can I can divide everything by 4, I think. So I should get 4x squared minus 15x plus 9 is equal to 0. And then I think, let me see. I go 4x x minus 3, 4 3 is negative 12, yeah, I think that's it, equals 0. And then so I get x is equal to 4/3 or 3, sorry, not 4/3, wake up Mr. K, 3/4 or 3. And then to find out y, I'm just going to stick these values, the 3/4 and the 3, into this equation here. So that will give me, my values will be 3. And if I chuck in a 3 in there, that'll give me 4 plus 2 or 6. Okay, so the coordinates will be 3/4, 3, or 3, 6. Those will be the values there. Now I think this next question, or some of it may be a repeated question, but nevertheless we'll do it anyway. We've got to find the range of f. Well, one way would be to write this out and complete the square, and perhaps we could take the negative 2 out. We've got x squared minus 2x. Yeah, I think that's right. Oh, is that right? Yeah, I think it is. Okay. Now we will complete the square. So it'll be x minus 1 squared minus 1, and that's equal to negative 2 x minus 1 all squared, and that'll be plus 2. Now that means that the range, so this is a minimum point, so we've got an MP, minimum point, sorry, a maximum point. Why is it a maximum point? Because we have a negative x which looks like this, negative x squared. So maximum point, and that will be at 1, 2, and therefore the range is fx is less than or equal to 2. Now for the next bit here, we've got to find the value of the constant for which g of x has equal roots, equals k has equal roots. So what we do is we first of all make our composite function. So we're going to put into g this 4x minus 2x squared. I'm going to put that into g and it should be equal to k. So let's do that. Now this value of is inserted for every x value in gx. So what we will do in our next line therefore is we're going to go 5 bracket 4x minus 2x squared plus the 3 equals k. Now that 3 you might be thinking, where the heck did that come from? This is this bit here. Okay. So I'm going to get negative 10x squared plus 20x plus 15 minus k is equal to 0. So now I've got a quadratic and I can now find out where it has equal roots. So when we have equal roots, that means one root, doesn't it? So in b squared minus 4ac is equal to 0 when we have equal roots. So what I'm going to do for that is I'm going to chuck in my b value, 20 squared, minus 4 times my a value, which is negative 10, times, and then for my c value, you can see that there are actually two parts to c. So we've got that, so I'm going to put that in a bracket so that I don't 0. So I get 400 plus 40 into 15 minus k. That's a bit messy, let's just fix it up. 15 minus k is equal to 0. So I get 400 plus, what's 40 times 15? Oh, hang on. I don't know why I've times that. I don't know why I've got a 15 there. Just going back a little bit, team. Yeah, just because I shouldn't have a 15 there. I've times that 3 by 5, which I shouldn't have. So this bit here is not 15. Let me just get the thing here, fix it up. See, good to check what you're doing. Plus 3 minus k. Now, so that means I will just need to fix up a couple of bits in here. So that's, these two brackets need to be 3 minus k, 3 minus k. Okay, now I think we're better. 40 times 3 is 120, minus 40k is equal to 0. And, well, if we bring the 40k across to the other side, I'm running out of room here, but I think it's 520 equals 40k. And so therefore k is equal to, what's that, 520 divided by 40, is that 13? 520 divided by 40 is 13. Yeah, so k is equal to 13. Now in the next one I've got to find the distance between the points at the beginning. So it's these points here that I found right in question 1, so I'm going to grab those down here. And this is just using Pythagoras theorem. So this is a pretty easy question really. We're going to go, the distance between those points is the distance between the x values squared plus the distance between the y values, oh sorry, that was the y values, plus the distance between the x values squared. Now, when you chuck that into your calculator, what do you get? I don't know, let's quickly check that. So I'm getting 15/4 for that one. Okay. Now the next one, oh, this looks interesting, could be tricky. Okay, so the diagram shows a circle with center A and radius R. diameters, that's CAD and BAE are perpendicular. Okay, right, that's helpful. And then we've got a larger circle B, centre B, and passes through C and D. And we've got to show that the we've got to show that the radius of the larger circle is r square root 2. Okay. Now, okay. Well, my first step would be to think, okay, from B to C, BC is a radius of the larger circle, and therefore we can think about this here as a right angled triangle. We know that BA is R and CA is also R, so BC is equal to the square root of R squared plus R squared using Pythagoras. So BC is equal to the square root of 2R squared, which is equal to the square root of 2R. Okay. Now we've got to find the area of the shaded region in terms of R. Okay, so this is a bit more complex, so we're gonna do a few steps here. First of all, I'm going to find out what sector CBD is. So I'm going to find the area of this. Then I'm going to try and find the area of this and the area of this. And then I'll subtract that from the circle centre A. So let's work on the blue bit, sector CBD. Well, the area of a sector, and we're using radians, using our formula is half r squared theta, where theta is the angle. Now you know that CBD is an angle of 90 degrees, or in radians we're going to say half times r squared and times pi over 2, which is what 90 degrees is in radians. Now r squared for this one, what is the radius of this angle? BC. Now it's not r, because remember we found that the radius BC is actually square root 2r. So now I'm going to insert that to here, square root 2, and I've got to square root that whole thing. I've really made a muck up of this, haven't I? Just delete that. So chuck in square root 2r and squaring that whole thing times pi over 2. Now when we simplify that, we're going to get half times 2r squared times pi over 2, and when we simplify that we'll just get r squared pi over 2. Now to find these red bits, I'm going to find, I guess, this whole area here, this pink area, which is half of circle centre A. Then I'm going to subtract those two triangles, which should give me the red area. So what we'll do for this is we're going to say the area of the pink highlighted area is a half circle, which is half times r squared times pi, because pi is 180 degrees. Now, in this case, the radius actually is r, because we're dealing with a smaller circle radius at this point. Now, I need to subtract from that two of those little triangles. Now, if we look at the little triangles, let me just show you what I mean by the little triangles. I mean this triangle here, right? And that's half, so minus half, minus 2 times because there's another one underneath it, right? You can see there's another one here, right? So half, 2 times half times r squared sine pi over 2. Now you might be thinking, what the heck is he doing there? Okay, we're using half AB sine C, so we've got an r here and an r here and the 90 degrees here, so half r squared sine pi over 2. Now, if we simplify this, what do we get? Well, we get half r squared pi take away r squared. Okay, because sine pi over 2 is 1. Now, if I want the, so what I've just found here, this bit here, is now those red bits, right? So I've got the blue bit, I've got the red bit, now I want the shaded bit, the grey shaded bit. So my final answer is going to be the whole circle, which is pi r squared, take away those 2 bits that I've just found, r squared pi over 2. Minus r squared pi over 2 minus r squared. Sorry, I could rewrite this, couldn't I? It's r squared pi over 2 as well. Okay, now hopefully you can see that we'll get pi r squared take away. Sorry, that should be plus there, shouldn't it? Because I'm adding these 2 things together. So it should be take away r squared pi over 2 plus r squared pi over 2 is just r squared pi. Take away r squared. And you can see that when we subtract that, we'll just be left with positive r squared. Okay, that was a tricky one. Okay, the next one I'm trying to differentiate and find the equation of a tangent at a particular place. So dy dx, I'm going to, maybe I'll use the chain rule. So I'm going to say u equals x plus 2, and so du dx is going to be equal to 1. Oh, this is nice and simple, isn't it, really? And then I could say y is equal to u cubed, and so dy du is equal to 3u squared. And then we just combine those together to get our final answer. So dy dx is equal to 3 u squared times 1, which is just 3u squared. And we can simplify that to 3x plus 2 all squared, because we know what u is. It's this. Okay, so that's that one. Now, we need to find the equation of the tangent. Now, we need to find the gradient. So gradient at -4 equals 3 into -4 plus 2 all squared equals, now -4 plus 2 is -2 square it, it becomes +4, so we get a gradient of 12. Now we just use y minus y1 equals m into x minus x1, so equation of a straight line, because we've got a tangent, and we just pop in what we know. So y and the x value is -8, so y minus -8 equals, now our gradient is 12, we found that out, x minus, and our x value is up here is -4, and this is going to give me y equals 12x plus 36 minus 8, or y equals 12x oh, sorry, that's not 36. My times table's shocking. It's 48, isn't it? 48. Okay, and then I'm taking away 8 from that, so that's 12 plus 40. All right. Okay, guys. Well, there we go. That is maintenance for week 9. Hope that's been helpful to you. All right. God bless.